Okay, so what you're going to do is, of course, go through, check your worksheet with my answers, and make any changes necessary to fix yours. So number one, it says a man hits a golf ball, which has a mass of 0.2 kilograms. It accelerates at a rate of 20 meters per second. The question is, what is the force? So of course we start out with our equation. Force is equal to mass times acceleration. We know that mass has to be in kilograms, so that's 0.2 kilograms times the acceleration of 20 meters per second squared. When we multiply 0.2 times 20, you get 4. And a kilogram, you remember a kilogram and a meter per second squared comes out to be the unit called a Newton. So we can just symbolize Newton, and then of course we will have a box around our answer. Number two, it says you give a shopping cart a shove down the aisle. The cart is full of groceries and has a mass of 18 kilograms, and it accelerates at a rate of 3 meters per second. We're looking for force. So once again, our equation is force is equal to mass times acceleration. The mass is 18 kilograms times the acceleration of 3 meters per second squared. 18 times 3 is 54. The units, once again, a kilogram and a meter per second squared come out to be a Newton. And then, of course, to finish this, you must put your answer in a box. On number 3, it says the wind pushes a paper cup along the sand at a beach. The cup has a mass of 25 grams. We need to know kilograms, so we'll have to come do that first, and accelerates at a rate of 3 meters per second squared. What is the force? So we know we're going to solve for force, but we know that mass in that or force equation has to be in kilograms. So the first thing I'm going to do is I'm going to change 25 grams into kilograms. And I know that for every 1 kilogram, there is 1,000 grams. So the grams will cancel. 25 kilograms divided by 1,000, that equals 0.025 kilograms. So I'm going to need that in my equation to solve for force. So force is equal to mass times acceleration. We know that the mass now is 0.025 kilograms times acceleration of 3 meters per second squared. When you run that in your calculator, you get 0.075, and of course a kilogram and a meter per second squared is a Newton. So on this one, because the mass was not in kilograms, we had to change it first. And then we had to run it through our equation. So you actually had to do 2 problems. You had to get that in kilograms, and then you could do this equation. In number 4, it says a runner has a mass of 89 kilograms, and he produces a force of 84 newtons between the ground and his running shoes. How fast does he accelerate? So they're asking us to solve for acceleration, which according to this equation is force divided by mass. So the force is 84 newtons. Now here's where I'm going to do something a little different. Instead of writing in, I'm going to break it down into the subunits. So that's really a kilogram times a meter per second squared. That's the same as saying 84 newtons. Mass then would be 89 kilograms. The reason I did that, because now you can see that this kilogram and this kilogram divide away, and 84 divided by 89 is 0.94, and the unit I have left here is meter per second squared, and that's a unit value of acceleration. So anytime when you're given force in newtons as part of your problem, you really want to make a newton into a kilogram per meter per second squared, so that you can see how units will cancel out in your answer. In number 5, it says calculate the acceleration of a car if the force is 450 newtons and its mass is 1,300 kilograms. So since we're going to calculate the acceleration is equal to force divided by mass. But again, to do this, I'm going to take the newtons here. I'm going to say 450 newtons is actually 450 kilograms times meter per second squared divided by a mass of 1,300 kilograms. So now you can see that the kilograms cancel with each other. When I divide 450 by 1,300, I get 0.346, and the unit I have, of course, is meter per second squared. So again, remember that a newton is equal to a kilogram of mass times the acceleration of a meter per second squared. So that's just something that we need to note when we're working these problems. It's always easier to take that force unit of newtons and change it back to kilograms per meter per second squared. In number 6, it says you push a friend sitting on a swing. She has a mass of 50 kilograms and accelerates at a rate of 4 meters per second squared, and we want to solve for force. So we know that force is equal to mass times acceleration. So the mass again was 50 kilograms times the acceleration of 4 meters per second squared. 4 times 50 would be 200, and we know that a kilogram and a meter per second squared comes out to be a newton. So this one I can turn back into newtons. So on this problem here, we're going to, it says how much force would it take to push another larger friend who has a mass of 70 kilograms to accelerate at the same rate 4 meters per second squared. So we're solving for force. Force is equal to mass times acceleration. The mass is 70 kilograms. The acceleration is 4 meters per second squared. 70 times 4 is 280. And again, a kilogram and a meter per second squared comes out to be a newton. So in this challenge problem, it says that you have a water bottle rocket that has a mass of 0.248 kilograms. The force that the Earth's gravity exerts on an object is 9.8 newtons per kilogram. That's the acceleration due to gravity. When the water sprays out at the bottom of the bottle rocket, it creates a starting thrust of 77 newtons. We want to calculate the acceleration. So we know that the formula for acceleration is equal to the force divided by the mass. And we know that the mass of the bottle rocket is 0.248 kilograms. We know that, but what we need to know is what the force is. Well, we know, because the first part of this really doesn't have anything to do with it, this idea here of the force of the Earth's gravity. We know that it's 77 newtons is what it's going to produce when it takes off. So we know that 77 newtons is the same as saying kilogram times meter per second squared. So we know that the kilograms will divide away. And then we have 77 divided by 0.248. Run that through your calculator, you get 310.48, and the unit left is meter per second squared. And again, you have to remember that a newton is equal to a kilogram of mass times a meter per second square of acceleration. So that's just something to keep. Probably make sure you have that on your note card. This relationship. You should. I told you to. It's up on this hood, but just double check that you have it on your note card.